British School of Leather Technology, and my project is investigation of the relationship between objective and subjective assessment of leather handle. So why we want to study leather handle? Because it's quite important thing. It indicates the leather quality when you buy a leather. So we study the feeling of the leather, which includes rough or greasy, or soft, or smooth, or roughness, or something. So the traditional way to assess it is by hand. Usually we have very experienced tanners to assess it. But now the popular way is by the DLC softness sketch. It is a very good instrument because it's quick, non-destructive, but it can't tell all the differences between a piece of leather and leather. So what we want to do is to characterize the physical properties of a range of leather types and investigate the subjective and objective relationship between the leather, and put forward a procedure and associated software to provide a reliable objective method of assessing leather. The method we're going to do to that leather is by physical measurement and panel assessment. To analyze the data, we're using principal component analysis and artificial neural networks. And the aim is to work out the relationship of the physical measurement and the panel assessment. So we had a collection of high-quality leather, and other than DLC softness sketch, we defined a variety of different physical measurements of leather, such as this one is the compression test. Through compression test, we got the parameters of thickness and the compressibility and compression energy ratio. And for stretching test, we got the extension of the stretchy leather and the thickness modulus and the energy ratio of stretching test. From the surface friction test, we got the parameters of surface friction and the linear distance. And this one is called three-port bending test. This one is the vertical loop test. And this one is buckling test. And this one is the drooping angle test. So we got the results of the physical test here. This data are normalized data, so we can see the difference here of maximum value and minimum value. Through this chart, we can see that not all the difference from these parameters are the same. So what we can do is select the most different ones from these parameters, such as thickness modulus or linear distance. But in later research, we found that the linear distance is not related to any attributes we want to assess, so we drop these parameters. And for indentation index, because the difference between max and min are really not big, so we drop this parameter as well. And for panel assessment, we use the sensory evaluation because this technology is usually used in food industry, and we think the feeling of leather is a kind of sense, and we want to do the same thing like product development and quality control to leather. So we want to use this technology. It required trained panel and standard test methods and controlled test environment. A panel with 7 panelists with different backgrounds were set up and trained for this assessment. They agreed on the procedures to assess the legal handle and a glossary of legal handle with definitions, and a questionnaire with 10 physical attributes which should be assessed in the assessment. And the scaling is from 1 to 5. We didn't take the test in a group, which means they all sit in a room and make the decision together. Because we thought that probably in that way they will influence each other's decision. So we did the test individually, but we keep the procedures and the environment same. So these are the results of the panel assessment. This is the result for level sample 1, and we have A to G panelist here, and they got the scores for each different physical attributes. We can see that for 5, they are actually, someone just think it's 2, but someone think it's 5. But this example is very extremely. So we think these are just a little error from the panel. And but for most of the attributes, we think the difference are only from 1 to 2. And the trends of the curves are almost the same. But we should notice that even panelist G gives most of the lowest scores. He gave the emptiness the highest score, which means the panel have different ideas on different attributes, not just because their scores are totally different from each other. And these are the average standard deviation of panel assessment. So we can see here for dry and firm, panel gave them the most different scores, which means if most of the panel gave the score 1, probably one of them will get score 2, and the other will get score 0. So the range are 2 actually. So we use principal component analysis to analyze data first. PCA is a technique to reduce the data dimension. So if we can think X1 to XP is the panel assessment data or the physical parameters, the PC1 can indicate that it's a combination of the linear combination of all these parameters. Usually, if we have P parameters, we will have a new component, P, the same. But because the last few components are really gave tiny contribution to the whole data, so we could just could be less than P. And so these are the data for physical measurement. So we can see here, component 1 can explain about 92% of the values of compressibility, and it can explain about 7 parameters. And component 2 can explain 3 parameters, component 3 can explain 2 parameters. We think these are the group of the data because they all got similar factors in it, but we still don't know what. And if we use, these are the 12 components we extracted from the original data. And if we use 3 of the main components, we can explain about more than a quarter of the whole data set. And we did the same to the panel assessment. We should conclude the the data into 4 groups. But for the last group, dry and tight, because at last we think it's more about visual thing, so we dropped off these 2 parameters. So mainly we have 3 groups. And what we want to do is select 1 important parameter from each of this group to indicate the panel assessment and the physical parameters of the letter. And we can see here, these 3 components can explain more than 3/4 of the data variance as well. So we want to use artificial neural networks to analyze the data after we group them. ANN actually is a computer modeling of the bi-neural networks. And the advantage of it is the learning ability. And the researchers proved that it can solve universal problems. So that's why we want to use it. And this is 1 neuron, and the input XO to XP. We assign a weight to each element of the input and the sum them, and let them get through a function called threshold function. Then we got the output. This is a very simple neuron, and if we put more neurons in, it will be like this. And if we put more layers in this network, it will be like this. Each neuron connected to each other, and from the input layer, we can get the output layer. So we got a 3-4-3 network, which means it got 3 input elements from physical parameters, which is thickness, dynamic friction coefficient, and compression and duration. And the output elements are stiffness, and thickness, and smoothness. We trained them with 10 samples to get the width and bias, and we tested by the rest of 3 samples. These are the data we put into the neural network. From this data, we can see that if the emptiness is high, the thickness is relatively low, and the same for the stiff and the compression energy ratio. But some of them are not like the green one and the yellow one. But we still can't just explain the relationship through this chart. So we got the predicted result from our artificial neural network. These are the samples we never been seen by the neural network, but when we feed in, it can predict the output. So the symbols with color in is the predictive parameters by the network, and the symbols without color in is the scores made by our panel. So we can see that it can predict sample 1 and sample 11 quite good. But for sample 3, the result for stiffness is not so good. But the difference is only about 1.5. So remember, our panelist has a standard deviation about 1. So this is not a very bad result. And this paragraph, this chart is about from the physical parameters to panel attributes. And this one is from the 3 panel attributes we have already predicted to the other 3 we haven't used in the neural network. So for sample 1 and sample 11, it's still the same. It can predict really good. But for sample 13, I think because the predicted parameters has already been away from the original one, so this one is not so good. But it's still just in 2 2 grades difference. And what we are doing now is still analysis the data and try to reduce the dimensions, because what we have done is just to select the data by hand. We don't have theory, so that means we don't know why these parameters can predict the other parameters. So what we're going to do actually is try to find the relationship between these data and to explain the subjective and objective assessment of leather handle. And we now got another collection of glove leather from a pizza company, and we're going to do another trial and to see if this neural network can work on all the other kinds of leathers. And then at last we want to develop an instrument to do this for people. Okay.